All right, I say that's pretty much time. So everyone, this is Taiob with this session. What the heck is a checkpoint and why should I care? Over to you, fella.
Okay, thank you everyone for joining. Thanks, Bob, for moderating the session. And I also want to thank the organizers because this sounds easy if you are just watching it, but I have some experience with what goes on behind the scene, right? It's a lot of work and to bringing it free of cost worldwide. So thank you. Plus making it available afterward, right? In as a recording. So thanks to the organizers. And also, I know there will be a QR code at the end, but please do give feedback. And not only my session, if you have attended the previous ones, please give feedback because I'm sure the organizers and the speakers, right? We are always looking to improve. And I can take raw feedback, right? Because, you know, I have 3 children. My mother-in-law has been living with me for 50% of the time in last 12 years. So you can give me raw feedback. You don't need to be too gentle, but constructive feedback. If you just say that you didn't like it, I really cannot do anything other than throwing your feedback. So you didn't like it, why you didn't like it, what can I do, what do you expected to see? If you put a little bit more details, I'm sure I can work harder next time. And the same for the other speakers also if you have attended. I have attended few, and I think mine was given at the end because of the intensity of these sessions. So I think I can maybe slow it down a little bit and bring everyone at ease, right? Because especially Hugo and Sander, everyone, Sylvia and Josephine, I watched all 4. Tremendous. So let's move ahead. I'm not going to talk about my Azure certification, but my contacts are here and you'll get the slide. So if you have any question, comments, or you want to follow up on anything that I'm talking about, you can contact me. Just remember the word SQL Worldwide and you'll find me pretty much everywhere. And I will respond to your questions probably in 2-3 days. And sometimes I have the luxury of knowing some smart people or smarter than me. So if I do not know the answer, I'll get it from them and then I'll get back to you. So why do we need checkpoint, right? So before I give any talk, I always ask this question that, why on a weekday during a business hour, somebody would come to listen to me, right? You have to have a reason. And unless you know why you want, you need checkpoint, you probably wouldn't appreciate this talk that much, right? So we'll repeat some of this into more details going forward, but just as a startup or as a primer, I'll give you 3 main reasons that why we need checkpoint in a database. And this is, pretty much any relational database do use checkpoint. And the main 3 reason is guaranteed durability. Now, what do I mean by durability? I'm going to come to that in few minutes. Other one is reduced crash recovery time. So, all the servers they run in a machine. It doesn't matter if you're running in Azure in your own data center, right? Behind the scene, there is computers, network, power, cooling, electricity, whatnot, right? So things can go wrong, power can go down, someone can, do some mistake, take a systems down, storage can go down. But as a database professional, once a user or an application get the acknowledgement back from your database that this operation has been done, we absolutely have to make sure with 100% guarantee that doesn't matter what happened to the system, that particular transaction is recoverable, right? So if you got money deposited in your bank, you just assume that it's there, right? You don't want the manager to tell you tomorrow that your money is not there, that they cannot find it, right? They don't see it in the database. That cannot happen. And when that happens, right, we need to recover if something goes wrong. So that needs to be faster, right? We cannot be waiting for hours after a system come up. So to reduce that time, checkpoint plays a bigger role. The other thing that a lot of people ignore or don't know is that IO to the disk are improved by checkpoint. So what do I mean by that? If we are doing a 1000 record update, imagine if we have to fetch every record to the memory, we update the record, and if we have to write it back to the disk, how long is it going to take us to do 1000 records to do update, right? So we do not do that. Oftentimes, or most of the time, we'll wait for the whole 1000 rows get updated, and then we'll do a single write back to the disk. And that's not also for every operation, as you will see. Oftentimes we keep doing that, our transactions, and we wait, and then every, we do a checkpoint. At that time, all these changes get written out into the disk. But if we have to do this for each change of every page of the data pages, things will take a lot longer, right? And it's probably not sustainable for many, many applications. So three main reasons: guarantee durability, reduce crash recovery time, and the IO performance. And we will go into details of some of these points. Now, so I talked about why do we need checkpoint. And the next thing is, how does SQL Server does it, right? And of course, this is a whole talk, but in summary, every time we do a checkpoint, we get a good point or a known good point. And if our server crashes, SQL Server knows that I have to recover, and I'll explain what do I mean by recover from that point. I do not care what happened before that point. I do not have to go back and look at those. Those are taken care of, it's guaranteed. So from that good point, I have to do undo and redo. And I'll talk about that a little bit more in details. Now, there are few things that will lead us to the talk of checkpoint. And if you do not know, or you're not familiar with these three concepts that you can see in this slide, it will be very difficult for you to understand checkpoints. So I will go through this very quickly, and which will lead us to the main talk. Some of these topics are very broad, right? Just the ACID property of transactional database systems, it itself, people wrote books about it, people have blog posts, pages after pages. So it can be a full talk for an hour, but I'm going to briefly touch those. So let's go. First, we're going to talk about ACID properties, and the first one is atomicity. And what do I mean by that? What I'm saying, what atomicity means is, if we have a transaction, it can have multiple statements, but we have to guarantee that either everything commits or nothing commits. And a famous example is, right, you take out X amount of dollar from my account, and I'm supposed to deposit it to Bob's account. What will happen if the money goes out from my account and it did not get deposited, right? Something happened in between, after the withdrawal and before the deposit. The server crashed, and now nobody knows where this money is, right? Nobody's going to like that situation. So in that case, what SQL Server has to guarantee that it has to put the money back to my account, right? So that's the rollback. So that's called atomicity. Next one is consistency. And out of the four properties that we'll be talking about, I think this is the most confusing one out of the four. And because consistency is guaranteed by some rules. And I can give you some examples, like primary keys, unique keys, check constraints, foreign key constraints. So these are there to make sure that we follow the business rules, right? I can have a column that can only take this range of values, right? That's defined by my business rules. Imagine we have an order and we cannot find that customer, right? Whatever the customer's order is, right? That will not be good, right? Because in case if there's an issue with the payment, we cannot reconcile. So these business rules are there to make sure that our data is correct based on and if you want to read more about this, there's a Brewer's cap theorem. You can go and read, there's a whole page about that. You can read that. But there's a lot of confusion recently with the NoSQL database that call eventually consistent. This is totally different. So this consistency term actually was available from 70s. This has nothing to do with the NoSQL multi-write databases. And the next one we're going to talk about is isolation and durability. So the isolation is, if I'm doing a work, right, I said, if I'm updating 1000 record and I'm not done yet, right? So I have done 400, I'm still going to do another 600. I do not want anyone to see the updates that I did for those 400 records. Why? In case if something goes wrong, and if I have to roll back, then you're looking at a data that really I did not commit, right? So it's really not looking at work in progress. Now, how SQL Server guarantees that? By isolation. But some of you, I'm sure you know about read uncommitted. But be careful when you use it. I hope you know why you are using it and when you are using it. The best advice I can give you is try not to use it unless you really have a compelling reason. So other than that, all other isolation levels will guarantee that that you're not looking at the work in progress, right? And the last one I talked about is the durability. What does that mean? It means what I said, right? Once a transaction has been completed, I'm guaranteed that the result set is persistent in the database. Doesn't matter what happened. If it's a malfunction, media failure, power failure, doesn't matter. We have to get that transaction back. Now, how do SQL Server do that? There's two things. One is called write-ahead logging, which we'll talk about more in details. Other one is a recovery, that undo and redo. And this is where checkpoint will play a major role, because once I have a crash, I need to know from which point I'm going to start the undo and the redo phase, right? And I know some of you might be thinking about accelerated database recovery, and some of these things you do not need to do, but I will come back to that at the end. I'll cover that too. The other concept I talked is clean versus dirty pages. So SQL Server cannot do any operation on the data page unless that page is brought to the memory from the disk. Doesn't matter whether you're doing a read, write, update, delete, whatever you call. You cannot do any operation when that data page is residing in your disk. You have to bring it to the memory. So when you bring the page to the memory, if the page in the memory and the page in the disk matches 100%, means you haven't made any change, then we call it a clean page. Also, after a checkpoint, all pages are considered as clean compared to dirty because you have written the changes to the disk. So now the pages in memory and in the disk matches 100%. And if your page in the memory and in the disk is not same, means you read a page and you made some changes and you did not write this page back to the disk. Now we call this as a dirty page. And there is a DMV called sysdmo as buffer descriptors, which actually has a column we'll see during the demo called is modified, where you can track how many dirty pages and clean pages you have in memory, and even you can look at it at object level, right? What object those pages belong to. And like I said, I'll show this in the demo. So the last one I talked about is a write-ahead logging. And SQL Server does this write-ahead logging for the reason of durability, right? So if a crash happens before a checkpoint or in between the checkpoints, that way we are not losing any data. So I will try to explain this in a step-by-step and see if it makes sense to you. And write-ahead logging has to happen before writing any dirty page to the disk. There are other systems or there are other mechanisms within the SQL Server other than checkpoint also writes dirty pages to the disk, and those also have to use the same write-ahead logging mechanism. So it doesn't matter what process is writing a dirty page from memory to disk. You have to do this before you can write a page. So, and I'll talk about some of those processes also. So let's take this example. Say like you have you issued a update statements for 1 million records, right? And either explicit or implicit transaction, you start with the begin transaction. SQL Server goes and look in the memory that do I have this page to do the update, right? And if it sees that no, the page is not there, it is going to fetch that page from memory to the disk. At that point, SQL Server is going to do a query lock and latch. And I'm not going to go into details of lock and latch. Latch is a lightweight lock. Latch is held only during the physical change of the data page, but a lock can be held on a page for a longer period. And once lock and latch is acquired on that page, then before even the update happens, it's going to generate a log record. And then you make the changes, whatever update you need to do. At that point, this page becomes dirty, what I just said in the previous slide, right? Because now the page I pulled from the disk and the page in the memory does not match, right? So right now, I'm going to call it a dirty page. As soon as the change is done, the physical change, we release the latch, but we did not release the lock yet. Now I said, about million pages. So most likely, you're not going to feed the million pages in 8 KB page, or 8 kilobyte is the data page size. So then you fetch the next page, you keep doing this. Once you are done with everything, then all these log records that got generated has to get flushed to the disk. And then we'll release the log, we'll send a commit transaction to the caller. Now, some of you might be wondering that what happened to the pages that I changed. Did I write those back to the disk, or did I forget? No, I did not. And that was my point, that SQL Server do not need to write the pages as long as the log records were flushed to the disk. So keep that in mind, and then we'll come back to this. Have any question at this point or comments?
There have been none.
Okay.
So, yep.
Okay. So I said that SQL Server has other processes that can also evict your pages from the memory. And there are, lazy writer and eager writer, and I'm not going to talk about this in details, but just so you know that these things also can evict pages and can write dirty pages to the disk. So the lazy writer is a system process. The main job of lazy writer, or the sole job, is to have a healthy amount of buffer available, or healthy amount of memory available for other stuff, right, inside the buffer cache. And the way it does it, it look at what time a page was last accessed, right? And it might not be for a change, right? It can be just reading a page. If someone is reading this page, or someone making a change to this pages. And every time we do a read or we make a change, there's a counter. It keeps tracks of the last time a page was accessed in the memory. So the lazy writer will come whenever it sees the memory pressure, and it will see that, no, I need to remove some pages, and it looks at the oldest one that was accessed, right? But lazy writer also can evict clean pages. So it can clear up dirty and clean both. In case if it's a dirty page, it has to follow the same process that I was talking with the write-ahead logging. So that's one of the process. There's something also called eager writer. And eager writer is another process. What it does is there are a bunch of operations in SQL Server. We call those minimally logged operations, like bulk insert, select into. When you do those, so we can do those very quickly, SQL Server allows this process to actually allocate new pages and write pages to the disk before even you do the commit. So these are only allowed for certain operations, not for everything. As you saw in the previous slide, that we do not write pages, even after the commit. But in this case, even before the commit, the dirty pages can be written back to the disk. And eager writer does that. So just so you know that there are other processes also can do similar operations that we are talking about. So let's get back to checkpoint. So what does SQL Server do whenever it issues a checkpoint? So I try to summarize this in 6 bullet points. There will be a log record, and we look at that. It will say that I'm starting a checkpoint. So just for starting and ending a checkpoint, you will see 2 log records clearly marking when it is starting and ending. And after that checkpoint log record get generated, that log record get written to the disk. And SQL Server has a page, we call it a boot page for every database. And the boot page has this log record number. You remember I said, whenever there is a crash, there is a known good point, and this is that good point that I was talking about. So if there is a crash, SQL Server comes up, and for each database, the undo and the redo phase starts from this log sequence number. So if your boot page is, is corrupted, your database would not come up. I think it's the page number 9 in file number 1 in your primary file group. I think it's page 9 is the boot page. And if it's corrupted, then you're not going to get your database back, right? It's not going to come up online. So if it is me, I'll probably open a Microsoft case, or I'll probably see if I can restore from my last known good backup, right? But if it's Paul Randall or Bob Ward, they'll probably open the hex editor and try to fix it, but it's not me. And I think Hugo talked about, why he doesn't use hex editor. It's the same with me. It's too complicated for me. I'm not at that level. So once that get written into the boot page, now all dirty page will get written to the disk. And when I talk to people, there's a major confusion. A lot of people think that at this phase, only the committed transaction, the pages that are related to a committed transaction will get written to the disk, but that's a wrong misconception. Every database, every dirty page, doesn't matter if your transaction got committed or if it's not still committed or on the fly. Doesn't matter. Up to that point, up to that log sequence number, at that moment, every dirty page will be written to the disk. So yes, you might be now wondering that if I'm in the middle of that transaction that I showed you with 1 million page, say like I'm done with the 200,000 and I have done a couple of pages and I'm still working on, now you write this to the disk, what will happen? And that's when the undo phase will come and not, will undo those operations because you have not committed that transaction. And again, if you're an accelerated database recovery, it works in a different way. So once you write all those pages to the disk, then there will be another log sequence number, checkpoint, which will get recorded, and it will say that I'm done with the with this checkpoint, right? There will be another record written to the log. And if your database is in simple recovery, something there is we call virtual log file. So your log file, transaction log file, gets sliced into a smaller chunk. Each chunk has a number. We call this virtual log file. They will get freed up, right? They will get freed up. They really don't evict anything. They'll mark that this section of my log file is ready for reuse. So SQL Server log file is a circular log file, right? So it's a continuously, you come to the end and then you overwrite the things. And if you cannot overwrite, that's when you get that famous error message that your log file is full and pretty much everything come to a screeching halt. For if you're in a full recovery model, even though in your VLF there is no active transaction, it still doesn't get marked for reuse unless you take a transaction log backup, right? And that is for there are other reasons for that. But if you're in simple recovery, and that also happens for 10DB, that you do not need to take a transaction log backup as long as there's nothing, it might get marked for it as an inactive, and then you move ahead. So I'm going to take a short pause here. If there's questions, I can take that. Otherwise, I'll go for a short demo, and then the next demo is a little bit longer. So we look at a few things, how the log records. We'll look at few log records. We'll look at checkpoints. How does this look like in the transaction log? And this will be a good time to take questions if anyone has any questions.
Yeah, I see none in the chats at the moment, but if anyone has one and wants to type
Sure.
it up, we can share.
Sure.
Let's see here.
I did refer a blog post from Paul Randall here. He wrote a lot of SQL Server internals when he worked at Microsoft. So he definitely knows more than me. So there are a bunch of a couple of ideas for this demo. I talked with him and I took some ideas from this one. I also put enough comments, so you can run this pretty much in any SQL Server, 2012 and above, hopefully, because there's one log record that did not get generated, I think pre-2012, and I have it in my comment. I'm using SQL Server 2022, CU4, latest and greatest management studio, just so you know, if you're wondering.
Okay, we have a question here from Slack. They ask, what happens with new modifications written to log when we are doing the checkpoint? Does it wait for the end of the checkpoint?
So when checkpoint is happening and someone is writing new stuff into the transaction log?
That's what I'm guessing they're getting at.
Yeah. So if you remember my previous slide, maybe I can go back. Writing to the log and writing the dirty pages is two separate operations. When the checkpoint is happening, you are still writing to the transaction log, means new logs are getting generated before you will send the commit to the caller. And it, when I say caller, it can be an application, it can be your SSMS query, whatever. Before you send the commit back to the caller, those transaction logs has to get flashed to the disk. And these are two separate operations, so don't mix these two things up, right? So if a checkpoint is happening, it's taking care of all the dirty pages. But if you're writing the new transaction at the same time, those transition logs has to get persisted before the caller is going to get the acknowledgement that your transaction is completed. If it's not clear, we can talk about it later on.
They said thank you in the chat, so
Okay.
I guess that answered the question. That's the only question I see so far.
Okay, so I'm going to create an empty database, 8 KB online. My database now. Nothing fancy here. I'm not promoting this, please do not do this. I'm just doing this auto-created statistics off just to keep the log records to the minimum, just for the benefit of looking at checkpoint log records. Otherwise, you get too many things and it's not easy to see. So do not do this anywhere. It's just for this demo purpose. I'm creating a single table called checkpoint demo with one column, integer. And now I talked about dirty page and clean pages, right? So we did insert here. So this page must be in memory, right? And Pinal Dave is a long-term MVP from India. He has probably over 4,000 blog posts, probably 5,000 at this point. He has this, and I just copied it from there. But I want to make sure that he get the credit. So now you see we have two dirty pages, belongs to this checkpoint demo table. And we're going to issue a manual checkpoint. I know I did not talk about manual checkpoint, but it's coming up. So we did this. We did a checkpoint and checkpoint. And if I run this now, same query that I just showed you, zero dirty page, two clean pages. Because this page has got flushed to the disk, so now I have the same copy. A lot of people misunderstand that these pages are not in memory anymore. SQL Server doesn't do that unless there is a memory pressure. SQL Server actually still keeps the copy in the memory in case if you want to read from this, right? So in general, SQL Server will not evict a page once it's in memory unless there is a need for space in the memory. So this page is now reside in the memory, and in the disk, but they're same copy. So we see them as a clean pages. Oh, this is the one I was talking about. So you see that, let me run this again. This right in the boot page, the last checkpoint time, this LSN, that's where the redo, undo and redo is going to start. But this record did not exist pre-SQL 2012. So if you run this in a machine, hopefully you don't have SQL 2008. I hope not. But if you have one, you will not see that record. Now, hopefully all of you know that SQL Server, we can also do two different kind of transaction, right? One is a implicit and explicit. Like when I did this insert, I did not say begin transaction and commit transaction, right? SQL Server automatically did that for me. So we call this an implicit transaction. But in this case, I'm just going to do an explicit transaction, means I'll say begin transaction, and then I'll do insert, but I'm not going to commit that. You don't want to do this unless you have a reason, why you are doing it, because the locks are not going to get released, and a lot of other processes will probably be waiting if they are trying to do something in the same object. But I'm just doing this here for the demo purpose. And so I did a begin transaction. I did insert. And if I do a checkpoint now, we started the transaction, right? But we did not commit it. And we did a checkpoint here, right? Start checkpoint, wrote in the boot page, end checkpoint. Bob, is this big enough, or I should zoom
It looks good on my screen. I mean, zoom it helps, but it was legible before, in my opinion, at least.
Okay.
Yeah.
So now think about this. We did this. We did this begin. We did not commit this. We did a checkpoint. So this page has been written to the disk. Now, what will happen if the server crashes? How would SQL Server know that this transaction was not committed at all? And it has to find that and undo that insert statement. So let's look at this. So it somehow needs to know this block sequence number, right? So I wrote this here. If we come here, LCX now, so we'll take this. This is the whole log record when the checkpoint happened, right? And let's put this in a new window. And then we're looking for this. This is in a reverse order, just, so you'll see this right here. This part right here. And this part is right here. So now, before I do this commit, if we crash, this log sequence number is in this log record. And during the undo phase, it will find that, and I can have many of this. I'm just showing you one. I can have 2, 3, 4, 5, 6. It will find that I have a record for begin transaction, whereas I do not have a commit transaction. So it is going to go and find out, what change was done, and it is going to find this log record from this log sequence number. It is going to see what change was done, and it is going to undo that. So let's do a commit checkpoint. And now you do not see that begin transaction or commit transaction, right? Because everything is done. We just have the log records for checkpoint, begin and end. Any question here?
We had one question that came in about, I'll put it here for benefit of the video. They ask, if dirty uncommitted pages get checkpointed to disk, and then we do a rollback, does that incur another disk hit?
I do not know. So if you, I'm not going to ask, I do not know at this point.
Okay.
I have to think about it a little bit.
Yeah.
Yeah, I do not want to just make up
No worries.
an answer. But whoever asked that, if you just send me a note, and I can even do some tests, I can find out and then I'll let you know.
Okay.
Yep. Okay, so let's go back to the slides. There's another demo. I'll show a few other things. So now we are back to checkpoint, right? So it took us almost 35 minutes to get to checkpoint. So let's talk about it. So there are 4 different kinds. As you can see in this slide, the first one is automatic checkpoint. And this was there forever. And this is controlled by something called recovery interval. If you look at SP configure, or there is also a DMV where you have all the config values, you will see something called recovery interval, and the default value is 0. So what does this default value 0 means, right? What does that mean when you see this? It's default when you install a SQL Server. And if you go to the Learn website from Books Online, if you read that, it will say that the SQL Server will try to recover in less than 1 minute. That's kind of the goal, approximately 1 minute. If there is a crash, SQL Server will try to recover within a minute. What is the problem here with this definition or with this value? So the checkpoints with automatic, it is controlled by the number of log records. It will see how many log records I had, and based on that, it issues a checkpoint. But it does not take into consideration that how many dirty pages are involved with each log record, right? Because I can have a single log record which can have many number of dirty pages. I can also have other way. I can have just one-to-one relation, but you don't know, it can be one to many. So it's really not keeping track of the number of dirty pages. And the other bigger problem that, somebody just asked a question about rollback. How about long-running transactions, right? I don't know if this happened to you, but I'm sure those of you who are working with SQL Server, especially with larger databases, I'm sure this happens at some point in your, the managers or the BP or the CTO is actually breathing on your neck, right? When is this rollback is going to finish? When is this rollback is going to finish? And the answer is, I do not know. I do not know. Never give answer, because there is no algorithm that you can tell exactly how many minutes and second. Even you see those percentage, if you put those in a graph later on, they are not linear. And if you're a junior, database professional, what they do, they'll restart, which is, shooting on your own feet, right? Because it's going to start the recovery from the beginning. So that's when you have to just say, relax, whoever you are boss, go back, relax, I'll let you know when the recovery is done. So in short, this automatic setting is really not reliable, right? Even if you read the documentation, it's clearly mentioned there at the end that I'm actually quoting from the Books Online. It says, this means that the recovery interval setting is unreliable. It cannot determine an accurate recovery duration because there are other factors that it doesn't take into consideration. Now, do you change the default? And when do you change the default, right? So there are certain scenarios, even if you go to Books Online, it may mention that if you, without you having a long-running transaction that rolling back, if you see that your recovery is taking a lot longer, or you are getting IO performance hit, and first you have to make sure, and I'll talk about monitoring a little bit, that it is due to the checkpoint. Once you are sure, then you might want to start tweaking that value, right? But be careful. Don't go from like 0, which is equivalent to a minute, suddenly don't go to like 10, 20, 30, 40 minutes, right? That will be not recommended, right? So doing a small increment. If you are changing over 60 minutes, you have to do an override if you're doing it with SP configure, if you're using that, right? So just typically leave it alone, unless you're really sure what you're, what you're doing. Manual checkpoint was introduced in SQL Server 2012. Before that, we did not have this, no, sorry, let me take it back. Indirect checkpoint was introduced in SQL 2012. You could always do manual checkpoint. So I take it back, my bad. So you can always issue, you saw me during the demo that I was saying checkpoint. So I was really doing manual checkpoints, right? But as we'll talk about indirect checkpoint, which was introduced in 2012, that kind of reduced the need of doing manual checkpoint. In old days, in SQL Server 2005, 2008, I had personally seen systems that people actually schedule manual checkpoint for different reasons, right? As a SQL Server agent job, very frequently. But after 2012, manual checkpoint came, so now you can control it per database level because automatic checkpoint setting is at an instance level. And so I was wondering, right, if people are still using manual checkpoint, and there is another thing that you can pass with the manual checkpoint is a checkpoint duration. You can tell SQL Server that I want you to finish this manual checkpoint in X number of seconds. And I've never used it personally, so I reached out to the community with the SQL help hashtag, which if you're in Twitter and if you do not know, this is one of the coolest things you can do. You can get answers within minutes and within hours, right? If you have a short question and answer. If it's a longer discussion type, you want to use, Microsoft Q&A or stackexchange.com. So I put this in, Aaron Button, many of you probably know him, long-time SQL Server MVP. He and, Travis and a couple of other people responded. So in summary, people still use it, but in a narrow scope, and all of them kind of said that they do not use a checkpoint duration. Like I personally never used it. So if I, have to make a list, it's like planned failover, performance testing. One person said, T-log shrinking, they do a checkpoint, and there is a blog post actually. If your transaction log is not shrinking the way you expect, if you do a manual checkpoint, then the shrink goes faster. I mean, overall, I'm not advocating you to do shrink. You should know your baseline, and you should pre-grow your transaction log to that size. But there are a couple of points that came in that why people use it. I personally used it in a very, very large database for always on availability group failover. The reason is that pre-2022, the buffer scan was single threaded, and in 2022 there is parallel buffer scan. So a manual checkpoint, and I worked with the Microsoft engineering team actually because we sometimes we had to wait for over an hour for the failover, and there are a couple of tricks that we found out that really speed up our manual failovers on very large systems. I'm talking about like 20 plus terabyte of databases that we issued a manual checkpoint before we do the manual failover to the other node, to the secondary nodes. So there are also internal checkpoints. I'll talk about the indirect at the end, that even for us not knowing or not doing anything, behind the scene, SQL Server does this for us. And why does it do it? So you want to make sure that whatever is in the disk and whatever is in the log matches 100%. So what are the times? I gave some examples. I'm not going to read this, but just so you know, during some of these operations, backup, snapshot, SQL Server does an internal checkpoint. So indirect checkpoint introduced in 2012, a lot better than automatic checkpoint, because this looks at number of dirty pages, not the number of log records. So it can do a better estimate when to issue a checkpoint. And the whole goal is to keep the number of dirty pages below that threshold, not the number of log records. And this is set per database. And a setting, if you go to your database settings, you'll see a setting named target recovery time, and the default is 60 seconds. This also persists with backup and recovery. Backup and restore, because this is a database level setting. So if you're bringing a database, you're restoring it to a different environment, this setting is persisted, right? You do not have to set that again. Now, from 2016, this will be the default behavior if you're creating a database in 2016. But if you are restoring a database from an older version, this is not set automatically. You have to manually set that up. So just keep that in mind. This is when I'm saying default is for new database that you create in 2016 or above. And if you are installing a brand new SQL Server 2016 or above, your model and TempDB also get the default setting of 60 seconds per database. And in 2019, there was another issue with especially in TempDB and very high transaction databases. People are getting non-yielding scheduler errors. And I'm not saying this was the only reason that people can get this error, but it was due to the dirty pages. It could not keep up by flushing the dirty pages to the disk. And in 2019, probably CU4 or CU5, this was fixed. And so I'm going to the next page, but there's one comment I want to make. If you have a edge case, or if you have any reason to disable indirect checkpoints in your TempDB, there is a trace flag which is documented, 3468. Look that up. I'm not advocating that, but you might have edge case. And Aaron Bertrand has some blog posts that I have in my reference page. If you need to do that, you can use the trace flag 3468 to disable it. I'm not going to try to explain the whole thing, but I put an URL here at the bottom. If you go to this was written by a Microsoft engineer, very nicely explained what the problem was with the non-yielding scheduler error and how did Microsoft fix it, right? So basically, every database get a list for dirty pages, and they get 128 for each one. And this also posed another problem after they fixed it, because you only have one, you have only one recovery writer. So if it could not keep up with the number of dirty pages, behind the scene, Microsoft actually could change some of the processes to help the recovery writer to move the dirty pages quickly to the disk. So like I said, if you are interested, go and read that. If you are not at 2019 CU4 or CU5, if you are below that for any reason, and you are seeing this error, I would highly encourage you to go and read that page, read this blog post, and this might give you some idea how to get some relief on that. There is some other improvement was done in 2016 around around checkpoints. So pre-2016, for the indirect checkpoint, the size of the IO was 256 kilobyte. It was changed to 1 megabyte. Also, the checkpoint process, what it does, it look at your current IO performance, and it sees how many IOs are waiting in the queue to get completed. And if it sees that it's taking longer time for the other IOs to complete, it will throttle back a little bit. And this value was 20 milliseconds. In 2016, this value is changed to 50 milliseconds. And there is another startup parameter, -k. You can mention checkpoint speed in megabyte. I've never used it, but I just want to make it aware, make you aware that it exists. If you want to set it up for, I don't know a reason that that you will use it. I will leave it to the system to decide, how frequently and what size IO. But there is the option there. You can set it up as a startup parameter. And checkpoint speed in megabytes is in a decimal number. So you can put how many megabytes per second that you do not, so your checkpoint cannot exceed that size if you want to restrict it for some reason that you have. Monitor checkpoint. Now, if you ask me, right, do I monitor checkpoints? No, I do not. Normally, I do not monitor, because checkpoints are happening all the time per database, right? So I do not monitor it. But the reason I'm going to talk about this, if you have I/O issues and if your workload is getting impacted, and you want to rule out or you want to be sure that this is either due to checkpoint or not due to checkpoint, some of these monitoring solutions might help you, because if you can correlate the timing when you are having the issue and at the same time, if you see the checkpoints are happening, and you can also put, we'll see this in the demo, you can enable some traceback that will give you a little bit more details, how many pages your checkpoint is writing to your disk and how much time it's taking. So it will help you to correlate, the two problems together. So that's why it's good to know. So the first one I mentioned here, buffer manager checkpoint pages per second, I don't use it, but it's there. If you go to your WMI counters, you'll see that. The reason I'm not going to use it, this actually aggregate all the checkpoints from all your databases, right? So now you really cannot isolate. Yeah, you don't know what belongs to, which databases, right? So really not a good one. Excellent event is a super duper if you're not using it. I know some of you probably still on hold and, make sure Erin doesn't know about it, then you can get into a debate. But there are two events, checkpoint begin and checkpoint end. You can, turn those on and you can filter by database, then you can monitor it. Also, there are trace flags that I'm going to show you today that you can use these three to monitor checkpoints. Oftentimes I get this question about checkpoint 10dB. I touched it earlier. This in 10dB, we do not have to recover, right, if there's a crash. I'm sure all of you know SQL Server, you get a brand new 10dB every time you restart your SQL Server instance. So the checkpoint only happens when the log file gets to 70% full. You can, a checkpoint get issued. You can also do manual checkpoint, and lazy writer can every pages that belongs to 10dB if it needs to. And VLF inactive happens like any other simple recovery database, as we talked about it before, right? Because you can always run a transaction in 10dB, right? Like any other database, right? You can do a begin, you can do a begin transactions, commit transactions. So it helps to keep track of the VLF and make sure it's reusable, right? But with any checkpoint, it goes and checks it. If there is no active transaction in that section of the log file that we call VLF, it will mark it as reusable. I get this question a few times. Someone actually reached out to me via email, and they thought that checkpoint will behave differently if you have accelerated database recovery. Now, if you do not know what's the accelerated database recovery, I'll show you two slides. I'm not going to talk about it. There is many full hour talk about accelerated database recovery. The one I can mention, if you go to YouTube, there's a channel called DBA VUG. There was a talk by John, I'm going to butcher his last name, John Dearduff. He's a Microsoft trainer. He has a whole 1 hour talk on accelerated database recovery from basic to goes to, very deep. So you can watch that. But if you turn this on, checkpoint does not change at all. The checkpoint behaves exactly either accelerated database recovery is on or off. So we mentioned this many times about redo and undo, right? From the good known point. And what I mean by that, exec, big, and LSN, we saw that during the demo, right? So if there is a crash at some point without accelerated database recovery, it does the analysis, find this point, does the redo, does the undo, and then your database is available. After the redo phase, partially your database can be available for certain things, but in general, you have to wait for all these three phases to finish. if you have accelerated database recovery turned on, then your redo phase get a lot shorter. You do not have to do it from here. You have to do it only from the last checkpoint, not from your last open uncommitted transaction. And you really pretty much skip your undo log because these are all in slog. And like I said, I'm not going to go there, but I put an URL. If you want to read more about it, you can go and see that. But the summary of this is that your checkpoint process does not change whether ADR is turned on or off. So I'm going to go back to my second demo. Bob, this will be a good time for any questions if anyone has any.
I have not seen any come across since our last check, so we're good.
Okay. So some of this I ran before all of you came online, just to save some time, but I will walk you through. I'm going to show you three things: monitor checkpoint, the behavior change for simple recovery database, and automatic versus indirect checkpoint IO behavior. Right? Why would you consider making using indirect checkpoints, and what can it do? How does the IO pattern change? So again, created a dummy database 8 KB online demo 2, and did this, but never do this, please, in any environment. Doesn't matter, dev, QA, prod, do not do this. I created an empty table. This has a couple more columns. And then I put some store procedure that I'm going to use, insert update. I used an algorithm from this to make it random. And then I had this 3 WMI counters that I'll be monitoring. And I wrote those here. You can easily search it. You can add these 2 more also. If you're interested, I'm not doing this just to keep it clean so I can show you what I want to show. And then I'm going to use a tool called Query Stress Tool, initially written by Adam Mechanic, and now it's in GitHub. You can download. I use it all the time. It's very nice for if you are making change to a single process or store procedure. Very quick to do a pre and post performance test. So this is the tool. I'm going to run this from 20 thread, 100,000 time iteration connected to my local database, local server, right? So let it go. So it's going to keep chugging and we can do other stuff. So first, let's look at the monitoring. 3605 is a very generic, it just redirects the output. So I'm going to turn on 3502 in this case. And I'm just going to recycle the error log. Yes, okay. And now let's read the error log. And as you can see here, let me, right? Details about checkpoint in your error log. You do not want to turn this on all the time, right? Unless you want to monitor checkpoint, because this will clutter your error log a lot. Now, this didn't tell us how many pages, how long it took, right? It only told us that there was a checkpoint. So now what I'm going to do, I'm going to turn on another one, 3504. Clear the error log or recycle it, just so I have less record to look at. Good. Beside everything we saw before, I see this. I know exact date time when this happened. So if I have an issue with my workload at the same time, and if you think it's due to your storage related, then you might want to start thinking about doing something with the checkpoint. Otherwise, you will not do anything. So I'm not going to remove these checkpoints. And like I talked about, you can also do it through extended event. I'm not going to show that just in the interest of time. And if we look at this now, you cannot see unless, okay, good. Now you can see all three. Let me increase it a little bit. So now you can see that our disk writes, let me rescale this, right? With this checkpoint, you see these IO spikes. Right? These are directly related to checkpoint, as you can see here, right? Every time the log file gets about 70%, this database is in simple recovery, checkpoint get issued, and we get this spikes. And this is a SQL Server 2022. So I have my indirect checkpoint turned on, set to 60 seconds. And if I change this to 15 seconds, let's see what happened. I'm expecting you will see this. And you don't see these spikes also. So I'm not saying that you go ahead and do it, right? Because now it's a trade-off, right? Now you are doing more checkpoints, but you have less, your IO peaks went down, right? So it's a balance. You have to decide, like what do you want to do? Like what do you need? What your problem is, right? If you can identify your problem, then you probably have to decide for yourself what you're going to do. But I'm just showing you some options that you have, right? Now we don't have these spikes at all. You can see it's a lot flatter, but I think we're getting a lot more checkpoints than before. Right? So it's doing it more frequently. And we can go to the other extreme if we want to. I can set it to 2 minutes instead of a minute. Now we'll probably see, a lot bigger spikes, right? We might not because of, the transaction log, 70% might show us the same behavior. Yeah, so now you see that those are back, right? You see those spikes are back because now I set it back to 2 minutes. And then I have some cleanup here. So that's kind of the demo I had. And cancel this. So these are some of the references. Aaron Bertrand did an extensive tests on some large databases. So you will see like I have a bunch of blog posts from him. There are a few from Paul Randall, and there are some are straight from books online. There's one from Bob Dorr. They're pretty nice if you really want to read more and want to understand. Aaron Bertrand have some pretty graphs, numbers, what improvements he saw by turning on indirect checkpoints for the databases that he upgraded from older versions to SQL Server 2016 and above. So you can go and read those. I will put my contacts again. And I believe we still have 12 minutes. So I'll take any questions, comments, or any discussion. But I want to thank Bob again, and thank you, organizers. Lee, thanks for hanging out all day and supporting this.
Always. I gotta support my people.
I know. I still have to thank you. You didn't have to do this, but anyway, but thank you.
Oh, I like that slide.
It is cool. Yeah, we got people typing in Slack, but I'm not sure if they're typing questions or congratulations or thank yous. We'll see here.
I have Slack on. I can go there directly and see what's there. No question, very clear. Okay.
Yep, we have a bunch of people typing, so it always happens at the end of a session. People go, "Oh, actually, I'll ask the question now." So we'll give it a couple of minutes just to see if there's any
Yeah,
questions.
no worries. Yeah, my kids are blocked. They know till 3:40 they can even knock on the door. Both door locked, so I'm good.
Hey, Teo, while they're typing, do you want to plug your event in the fall?
Yes. Oh gosh, thank you. So
You're
I'll plug in few because he gave me opportunity. June 9th, Bob Ward and Bakudi together coming to Massachusetts, MTC Burlington, whole day workshop SQL Server 2022 for $75 only.
Wow.
I paid $550 last year at Pass. I'm not going to ask for a refund, but I'm only charging $75. This will include your breakfast, lunch, tea, coffee, warm cookies at 3 p.m. We go big time on food. Though Bob will probably know. Bob was from, I don't know, Bob was here for SQL Saturday. If any of you are here, you will know our food standard. So we are just covering the food cost pretty much. So that's June 9th. And then in October 13th, Brent Ozer will be here, full day pre-con, MTC Burlington, followed by SQL Saturday Boston, October 14th, which is a Saturday, and Brent will be here on Friday. So if you are in New England area, or if you want to come and see the fall or start, in June, you want to just see how we transition to summer, come for a Saturday, Friday, come here, stay on the weekend, and then you can go back on Sunday night, right? $75 only. Bob and Bakudi together, right? So, yes. Often, if changing the checkpoint settings interval will make significant difference on a database using a SAN for the storage instead of physical disk. You have to test it, right? So, your storage, right, SAN or physical disk, I assume that at some point it would show itself as changing the network load, going from the server to the SAN. Again, I would do a small increment of change in the setting and then see, but before even you do that, you want to, I really want you to know that what your problem is and what your target is, right? What problem you're trying to solve. If you do not know, I'd rather leave it on SQL Server to do that. So.
And then there's one more question in the Zoom chat here.
Yeah.
If you don't have that handy, I can read it.
Yeah, no, I have it.
Okay, cool.
Would there be a reason to kill a checkpoint speed? If so, what would happen, or is there ever a reason to do so? I am not sure if it will let you do it. I haven't tried. Anthony, Andrew, Bob, anyone knows?
You can kill anything, can't you?
There are some system speeds, right? It will tell you that. I don't know what it will come with them, right? You'll see some blog posts like,
Do you see TG's comment? Because you can kill anything, although he says the next command is to restore.
Someone said post URL for the conference. So sorry, I'm going to do a little bit of shameless plugging here. TJ, thank you very much. So I've never tried, so I didn't want to but I love it. So.
Bob, did that question from Slack get asked and answered?
The one that you pasted into.
Yeah, I put it just to you, not to the whole group.
Oh, you put that to the whole. Well, yes, but Taiob answered it already with the changing checkpoint settings. Yeah, so sorry, I didn't realize it was just to me. My bad.
Well, I was just letting you moderate. I just didn't know if you saw it.
So where can I put the Eventbrite? Someone asked post the URL to the conf. Should I put it in the chat or no?
If you could drop it into the Slack channel, that'd be fantastic.
Okay, I'm gonna do that right now. I just want to make sure that all of you are okay, and I didn't want to
So for his SQL Saturday event that's happening in October, you can just go to SQLSaturday.com and scroll down, and it'll be Boston will be on the list for upcoming events, and it's October 14th, right, Taiob?
Yeah, it is there, and this is for the Bob Watts workshop. If you want to sign up, and it has more details what it is, and then the SQL Saturday, like Lee said, go to SQLSaturday.com. It is now happening more frequent, all over the country. So depending on your area, so there are other ones also, like great ones. So next command after the restore.
Okay, can I grab the screen off you, please?
Yes, you can. Thank you, everyone. Thanks for.
No worries. No, thank you so much. That was an absolutely amazing session. Okay, let me